In this video, we will use time domain beamforming technique to reveal brain activity related to a stimulus. As an example, we will work with an MEG dataset which presented a point cloud to the subject for short durations. In one case, the point cloud moved towards the subject, in the other, it was static. The screen shows the waveforms of 122 MEG sensors in a whole head recording. I can see the trigger events at the bottom of the screen. Trigger code 1 denotes the motion stimulus. Using the ERP button here, I can define the paradigm for this experiment. Let me load the predefined paradigm for this experiment. The condition motion has 131 matches. I can now scan the data for artifacts. The scan reveals only very few trials with bad signals, which I can exclude here using the slider. Moving to the Average tab, I can now select the condition of interest, my motion condition, and then click the Beamformer button. The Beamformer is computed by creating a spatial filter for the data covariance inside the signal interval and contrasting this against the baseline interval. So first, I need to define my signal and baseline intervals. Of course, it is somewhat difficult to know what the signal interval is without seeing the cumulated effect of many stimuli. So we can get this by clicking the button Toggle Butterfly Plot. Now we see clearly the effect of the stimulus, rising about 100 milliseconds after the stimulus. If I set my interval from 100 to 190 milliseconds, I can grasp the bulk of the stimulus-related activity. And I can see the interval plot in the picture here once I leave the edit field using the Tab key or clicking somewhere else. Now I need to define a matching baseline interval. I will vouch for -100 to -10 milliseconds. It makes sense to make the baseline interval the same length as the stimulus interval. Finally, I will use the Tab key to go to the common interval. This interval should best cover the complete interval between baseline start and signal end. Then I can click the OK button to start the computation. After accepting the clinical usage information, I get my Beamformer result. Let's scale up a little and use the toolbar button here with the M for maxima to browse through the maxima of the Beamformer image. The image was already sliced at the location of the first maximum. The first two maxima are in the primary occipital areas. And then I get a lateralized third maximum in the motion processing brain area in the right hemisphere. I can change the Beamformer parameters in the image settings. First of all, please note that BESA by default uses a bilateral beamformer which automatically scans for common activity in the contralateral hemisphere. This is super helpful when dealing with correlated activation, like auditory signals, for example. If I use the common weights and recompute the result, and also go back to the first maximum, the result is a more focal beamformer image, as you can see here. I can even compute the time course of the image. Let me make the image a bit smaller, maximize the whole window here, and now go to the settings again. I can use the noise normalize weights approach. Now I can set a cursor by double-clicking here into the maximum of the global field power. This is the initial peak, and I can see my activity in the primary visual cortex after scaling up a bit more. But now, when I move the cursor towards the second peak using the mouse wheel, the activity lateralizes in both hemispheres. It is quite possible that I'm mainly interested in the difference between two conditions. Let me see what the difference in processing is between moving and static point cloud. I can work again with the same settings as before. Only now will I work with a control condition, my static stimulus. You will note that now, the only interval I can set is the signal interval. I can rerun the butterfly plot computation and then toggle to see the butterfly plot of my control condition, and again to see the target condition. Now let us see the difference between the two. I can see, after scaling up again, that as a result, now my first maximum with the highest activation lies in the lateralized area. And also another of the highest maxima is in the contralateral motion processing area. So, in conclusion, the beamformer analysis showed that the primary visual processing step is similar between the two conditions, but the secondary part is not. Thank you for watching.